I want to just jump straight into the question. So let's start with 2018. What in your mind was the most significant development technically in 2018? We obviously had like a giant price downswing and everything else, but from a technical perspective, what did you guys think was the most significant from your perspective?
I'd probably say Mimblewimble. It's a pretty substantial improvement in applied cryptographic methods of obfuscated transfer.
Okay. All right. What's your answer?
Well, for me, once Segwit got approved, Lightning Network was finally possible, and we saw the mainnet for Lightning Network, so it went live. So this is probably the most exciting thing for me.
Yeah, I'll agree on Lightning Network as well. And in fact, I think Mimblewimble is a bit overrated because it still has the same scalability as Bitcoin. Ultimately, it improves your constant factors, but fundamentally, the way it's going to end up working was going to look quite a lot like Bitcoin.
Well, let's get into that because I do want to talk about scaling a little bit too. What do you feel like are the restrictions of Mimblewimble that make the scaling property similar to Bitcoin?
I mean, it's really quite simple. It's that I think the term they use is a kernel, but long story short, every transaction you do on Mimblewimble, you can compress it a lot, but there's still a bit of data that's left over. And that data has to be kept around to be able to go and verify everything fully to the same standards as Bitcoin. So right there you have a system that doesn't actually fundamentally scale better than Bitcoin. Whereas something like Lightning, I go send you like a couple tenths of a Satoshi to go buy a painting, and that transaction, the data for that transaction, only ever exists between two parties and gets deleted.
Yeah. Only the people that need to know about it. Whereas it's a broadcast network, Mimblewimble is a broadcast network, much in the same way that Bitcoin is. That is, everybody has to know about every transaction, versus something like Lightning, where only the parties that are involved need to know about it. Johnny, do you have a response to that? Because I know that you like the confidential aspect of Mimblewimble.
Yeah, I mostly believe that people have bought into the scale matters too much narrative. It's a narrative that Silicon Valley loves to push and loves to kind of harp on. So I mostly think that the context for development should be cognizant of the current reality. So the current reality is that most of these systems actually don't have a problem with scale right now because there's not enough users for them to actually have a problem for scale. So to hyper-focus on that as the single point of contention is kind of ridiculous.
But see, I think you're ignoring a security issue, though, which is that failure to scale well is a security vulnerability, because even though you may not actually have the users to need it, you can have the attackers who will go flood the network with bullshit.
I would also argue that's not a failure. Like when attackers flood Bitcoin, it gracefully handles the attack via the accrual of additional fees, which have hurt the attacker in the long run, and ultimately the system returns to normal functioning behavior after the bankruptcy of the attacker.
This brings up a really interesting question, though, about attackers and scaling, and how important is scaling? Because I think that's ultimately what you guys are talking about, and of course that has a big deal to do with a lot of the verification that you have to do, and the data that comes in and all the CPU processing. Like, how important is it to like how much does it matter? I suppose is the ultimate question here. Thoughts?
Again, I would say like it's probably the biggest security problem you have.
Scaling.
Yes. And part of it too is because security isn't just technical. In the context system like Bitcoin, security has PR implications, security has economic implications. If I can do something like say, well, all right, 9 months of the year, your gummy bear vending machine works, but 3 months a year it doesn't. Because I've artificially pushed the prices up. There's enough stickiness in people's usage of systems that they're going to stop using it. Yes, the transaction fee market certainly allowed this to gracefully handle this, but there's lots of sort of social and economic ways to make the effects of an attack worse than it really should be.
Your response, Johnny?
I mean, Peter's correct in that the characteristics of scale over time have to be addressed in order to make it so that functioning applications, can gracefully handle scenarios where fees are rapidly accelerating and people have divergences in their expectations of the behavior of a system versus the outcome of the system in the event of an adversarial nature or an adversarial constant nature, I guess. But I wouldn't say that thinking about scale as the primary issue is the best way to approach these kinds of problems, because in a lot of cases we don't actually have long-term solutions to the kinds of scale we need, like the verification challenges of everyone can fully validate system. We don't have solutions to those in the long run that actually change the characteristics of everyone fully validates. You have to make trade-offs to fundamentally change who can fully validate.
Right. Well, so I guess the big trade-off question right now is scale. Well, privacy is the main thing that I think interests you, Johnny, and Mimblewimble. But there's also this other aspect of, they launched their own coin. Well, there's two projects right now, Beam and Grin, that are implementing Mimblewimble. They do have certain privacy properties that maybe Bitcoin doesn't have. How important is privacy with respect to scalability for you guys? Let's start with Jan, because I feel like Jan's just sort of been sitting there while the three of us have been talking.
Well, we were here for the engineering part of the mining industry, so like my opinion on these two implementations, I personally like the green one, and like two reasons. There's no developer reward in there, and it's in Rust, so which is like the new religion today. And if you ever want to do a new project in your company, it has to be some language, like just do it in Rust. But I have one problem with their project, and that is like I don't understand why would you launch an altcoin with a new proof of work algorithm, and again trying to convince people with this story that you should do it on GPU, there will be no ASICs. But basically efficiently what you're doing is you're just pushing the technology boundary higher, and you're making it more difficult for people or companies to actually enter the industry. And if this particular Mimblewimble implementation ever catches up, theoretically, if it should ever replace whatever we have now, Bitcoin, whatever, it's not going to happen probably, then we will have a new race for the mining, and the devices are going to be substantially more complex than what we have with mining for Bitcoin. So this is the thing that I don't like about it.
So the argument why they're not necessarily bad is fundamentally this, which is that Bitcoin may at the base layer, and I do fundamentally believe Lightning changes that at layer 2, but it may at the base layer lack certain fungibility characteristics that may matter for the concept of sound money. And as a result of that, it may be useful to have a hedge against Bitcoin in the sense that you have a secondary system that has better fungibility characteristics at the base. Whether or not that thesis holds up, time will tell, markets will tell. But ultimately, they're not necessarily malicious for issuing their own coin or having their own secondary asset as a result of the fact that they're betting or gambling or making a play based on the fact that essentially Bitcoin can't have those base fungibility characteristics without rapid and invasive changes at the base layer.
Would Mimblewimble have been better deployed as a sidechain?
No.
Please explain.
Well, now I'm going to assume you're talking about, say, a merge mine sidechain. And
I mean, any kind of sidechain you can think of.
all right, so merge mine sidechains, reality is they're insecure. You can attack them at zero cost, and they go screw up the parent chain. If anything, the fact you can have merge mining is a major security vulnerability in proof of work, and unfortunately, I don't really have a good solution to it. It is what it is, and there isn't any clever way to stop it. Where now for a centralized sidechain, I could buy that Mimblewimble could have been a decent centralized sidechain, although obviously get very high regulatory risks of people shutting down the central actors. And I guess the other thing with Mimblewimble as a centralized sidechain, you got to ask, well, why would you bother with the Mimblewimble protocol? Why wouldn't you do like, say, Zcash with CK Snarks? That's much better privacy than what Mimblewimble can get. And in an environment where it is okay to chuck away history, because it's a centralized system, you can always create a new one. The technical downsides of ZK snarks don't really seem to matter that much. And the trusted setup, I mean, so what? It's centralized sidechain. The trusted setup's the least of your worries.
Right. If you already have a centralized setup, then trusting that centralized entity even more with the setup isn't much of a.
And remember, when you say trusted setup, that's a very different type of trust than ongoing trust.
Right.
It's a one-time thing. Yes, someone may have the keys to inflate your currency, but it's a one-time thing. If they didn't in the first place, they now can't create it. Whereas in an ongoing trust, Blockstream's liquid sidechain is a good example. That's an ongoing trust system. At any moment, the fiduciaries, which is, 10 or something, could get together and take all your money.
11 of 15, I think. Yeah. Okay. So let's move on to some other topics. SegWit version 1 is coming. It looks like. What are your perspectives on how that will change Bitcoin going forward?
So I'll go first. Well, for me, when I read the proposal from Greg, how he's gonna combine Taproot and Mast and Schnorr signatures, I think this is an amazing improvement for Bitcoin in terms of privacy, and I think it's gonna allow new projects show up that would be actually using these features. Yeah, well, that's it.
Yeah. I mean, how about you, Johnny?
I think it's another 17 to 25% scale bump too, which is always a nice win in the event that people use the new signature
Is this
sets.
through Schnorr?
Yeah,
Okay.
the Schnorr is like a slightly better signature schema.
Well, I don't think you're using the DIR format anymore, so
Yeah,
that takes off 10% off.
Yeah.
signature.
So, and then there's, Graftroot and the Mast constructs can enable a lot of really cool, relatively on-chain kind of contracting arrangements that we can't support right now without tons and tons of infrastructure or application infrastructure. So it's definitely compelling, and it's definitely a well-reviewed proposal.
Okay. How about you, Peter?
The simple truth of it is I haven't bothered looking at that stuff at all, because I think I know enough about it to know that it's relatively boring, and that's a good thing. You want simple incremental improvements that are better and kind of unexciting and will probably get deployed and it'll go off without a hitch.
Well, I mean, how about stuff like Musig that comes along with Schnorr, right? Like that allows you to have multi-sig without anybody on chain knowing about it.
I'd call it incremental improvement.
Really?
Yeah.
Okay.
I mean, it's a good thing, but it is still an incremental improvement.
Okay. And how about the effect on Lightning? Because we have proposals for SIG hash no input. Obviously Schnorr is going to help with that as well. I mean, do you think it changes Lightning and makes it easier to code? I mean, what are your perspectives?
I mean, when you look at Lightning, they've managed to go and take frankly, a relatively complex technical protocol and get many different implementations of it relatively quickly that actually work reasonably well. So yes, making that simpler will help, but I think what they've actually shown is that they can still deliver a working product, even with a protocol as complex as it is. And the one potential downside, although this may not actually matter in practice, with how the protocol evolves, is some of the great, I'm totally forgetting the technical term, but anyway, one of the new sort of Lightning proposals where, where essentially there isn't necessarily punishment.
Oh, okay.
That does scare me because it changes the game theory of it a bit.
Right,
But
I haven't heard that proposal. Okay.
Someone's going to have to remember the name for me, but anyway,
Okay.
yeah.
All right. Johnny, your thoughts?
I think the splicing mechanics that we get as a result of the new signature schemas and the additive schemas are really cool. Ability to draw down and draw up from existing Lightning balances by essentially additive mechanics on the main chain are really cool. And it lets us do things like all in and all out coin joins much more easily when we're entering and exiting the Lightning Network, which I talked about before. It's very compelling.
Yeah, yeah. There's, I see a theme here. You seem to be excited about a lot of the privacy features that are coming. Yeah.
I don't I don't actually think humans have privacy anymore. I don't actually think it's really a possible thing for us to have. But I do believe that our money can have fungibility. So and I think that is kind of going to be a major component of speech in the future. Really, is the extent to which your money is fungible.
Oh, interesting, interesting. Yeah, and your thoughts on SegWit version 1 and how it affects Lightning and how it affects Bitcoin in general?
Well, I'm not a pro on Zcash no input, so on this part. Well, we kind of covered this with the Taproot and Must thing. Again, to repeat myself a little bit, I was very excited about how Greg was able to explain that, even though it's not very exciting for Peter, but I was thinking, well, essentially musts are about, you have very complicated smart contract scripts, and at some point you only have one branch that you want to reveal. But his proposal was that, what if both parties agree to do some signing, and that you could not even tell apart this special transaction from a regular payment to some arbitrary address? So this is the exciting thing. If this comes with SegWit version 1, it will improve the privacy and allow like those complicated smart contracts to run on Bitcoin blockchain as well.
For me, it's interesting because you guys are all pointing out sort of new use cases and stuff that are more privacy related. For me, the bigger one, I suppose privacy is related to security, but the fact that you could secure it in different ways, using Schnorr and Music, something like that, that to me is a little more interesting because ultimately, being able to keep your wealth and not have it be vulnerable and having another option in case somebody breaks ECDSA but not Schnorr, something like that, that to me is actually kind of significant, having another option there. What your thoughts on?
I mean, if ECDSA gets broken, there's a pretty good chance the thing that breaks it will break Schnorr. Equally, I mean, if ECDSA does get broken, that's a massive problem for Bitcoin because suddenly huge numbers of coins with, that whose private key is being lost suddenly flood the market. We have all kinds of very awkward decisions to go make about what we do about it.
Yeah, that is true.
I think those kind of scenarios could easily kill Bitcoin.
They could, but I like having the additional
I guess the big problem with that is like what you're really doing is actually, in a sense, adding a vulnerability. Right, because now you have two different ways of stealing coins. You may not have two different ways of stealing one particular coin, but stealing coins in general, if that's possible, that can be, I think, a death knell for Bitcoin.
So if you can reverse, if you can find the pre-image of the hash function or something like that.
I'm just saying, like from a sort of PR and economic point of view, anything that lets people steal large numbers of coins is potential death knell for Bitcoin. Reduces confidence in the system. It creates all kinds of PR problems. It creates economic problems once coins flood the market. It's just a terrible thing. And I guess fortunately, the way things are looking right now is there's no particular reason to think any of this is going to be possible. Schnorr is being reviewed to death for, what is it now, for 20 years or something, 15 years? Yeah, 25 years.
Yeah, it ran out of patent recently.
There's been so much effort looking at this stuff that really the most likely thing to happen that would make this insecure on a big scale, due to crypto break is quantum computing. And frankly, there's a good chance quantum computing isn't real and it'll never happen.
Yeah, that much I agree with. The thing I guess I would ask is that really true? Is theft a real enough threat to Bitcoin? Because we did have a 51% attack on Ethereum Classic recently. And what was really interesting about that was that it actually didn't go down very much. It was almost like the market treated it as, just theft of somebody's coins that wasn't careful enough. So,
but it's not a big scale theft.
Well, I mean, so Jan, do you want to talk about 51% attacks and your view from a miner's perspective?
Well, we kind of have an ongoing attack here already. It's not by centralizing the hash power, but it's something that not too many people do realize, but when you look, what is the percentage of different types of hardware that are, for example, mining the Bitcoin blockchain, and who are the manufacturers, and what are all the background things going on lately, like with the firmwares being like closed source, nobody really knows what the units are doing. Like we were the first one who came up with the analysis report about the why the S9s are able to do an ASIC boost, and we were always wondering like why is nobody using it, even though the standard was in there. And it's like really puzzling still. If you look at the number of ASIC boosted blocks, and I'm sorry, I just a little bit branched off the original topic.
Yeah, that's
but,
fine.
but
You're talking about
it's
version rolling ASIC.
right,
yeah.
But this is an attack surface. Basically, the direction I'm headed to with this explanation is that nobody knows if the Chinese government can switch flip the switch, and suddenly we're going to lose some hash rate. Because the hardware itself is not audited, it's not open sourced, it's just, so the crypto technology, the transaction, all these things for Bitcoin are open source, or they're being audited. There are like really educated people who are working on it, but nobody cares about the mining really. And it's actually the mining making this possible, all these toys that we're talking here about to work. So,
Well, so our 51% attacks, I guess, as disastrous. I think Peter's made the case that it would be a complete PR disaster, that a lot of people would lose money, that sort of thing.
No, I would say you're talking about two separate issues there. 51% attacks don't enable large-scale theft of coins in the way that a crypto break does. And the reason is that we have full nodes and everyone validates. You know, that's the thing that makes 51% attacks a lot less scary than they would otherwise be. Whereas, you know, if we weren't validating, a 51% attack would mean miners could do whatever they want. Right? And yeah, it's funny, you actually see this a lot in like academic papers about Bitcoin, where they very misleadingly, or in some case I'd say straight up lying, go and describe Bitcoin as something where you're making the assumption that the majority of miners are honest. And in cryptography, honest means following a protocol, exactly. You know, even when it's more advantageous to do something else. You know, Bitcoin doesn't have this issue because we go validate and because we have this incentive model. And because of that, a 51% attack means you can steal money when you can do a reorg, when you can roll back, or for that matter, shorting the coin in general. But you can't steal money en masse away just being able to, you know, forge a signature can.
Yeah, you have to essentially do it with someone who's participating in a transaction on as your counterparty.
Right. So I don't think I was very clear. Do you think a 51% attack, like what would be the consequences of something like that on Bitcoin?
More alarming would be like a 51% attack where the attacker denial of services all transactions. That's a far more alarming scenario than one where coins are being stolen from traders or people who are participating as counterparties in the adversary's kind of approach. I don't really, I think a lot of those aspects are kind of mitigated because of the Coinbase lock time anyway, so the extent to which that those attacks have any kind of range, I think it's limited to something like 17 hours anyway, but assuming miners spend their initially Coinbase locked coins. So it's got pretty limited range basically, whereas the denial of service kind of approach plays much more into Peter's expectation or consumer expectation when it comes to Bitcoin, is that when you send a Bitcoin transaction, eventually it will propagate and eventually it will be included in a block, assuming you follow, fee structuring. Whereas if a hostile entity is essentially denial of servicing all productive blocks by producing non-productive blocks, that's a much more alarming scenario.
All right. Another topic that's been on Twitter a lot more recently is Neutrino and Spv. So I think Nicolas Dorier had a tweet that said something to the effect of, I don't understand the hype around Neutrino. Shouldn't we all be running full nodes? Your perspectives on whether or not users should be running full nodes. Is Neutrino good enough as a light client protocol to I encourage users to take it up. Your thoughts?
So Satoshi talked about this a lot, about the need for a kind of flexible, useful SVB client. I don't know about Neutrino personally myself. Either of you two, you can speak to it. But the extent to which we can develop or utilize a lightweight SPV that gives you some guarantees, not all. Core has been talking about that a lot. Peter's pretty hyped on that too. The idea that we can get to kind of a middle ground where you concede some trust barriers, or you opt into that concession in exchange for being able to lower your resource burden. But there should be no expectation that concession is something that must apply network wide. You must opt into that concession. It's not something that you can be mandated.
So
or
if
should
it's
be.
voluntary, you're okay with it?
To the extent that you understand the person who's opting in, who's voluntarily opting in, to the extent that they understand the trade-offs that they're making, yes.
Okay. Peter, your thought?
So first of all, I'd say that Neutrino, purely as a protocol to get information from a peer, I mean, belies obvious, improvements over the status quo. But light clients are just straight up dangerous for the ecosystem. And I would actually advocate a modification of Bitcoin protocol where garbage is allowed in blocks.
What do you mean by garbage?
So this is like the client-side validation, viewpoint where, where essentially there are no rules for what is allowed in a block. Thus, what a transaction means is something you have to go determine purely client-side. Because if you don't do that, someone can go put garbage that makes you think you got paid and you actually didn't, and that block won't be rejected. That I think is the level we actually need crypto protocols to be. Because all this stuff about intermediary things where this sort of works, but if miners collude, you're really screwed. I think creates very, very, very dangerous consequences for Bitcoin. On the other hand, I would say things like what Electrum could have been, where you had reasonably trusted but auditable third parties that you can connect to and download information, and they'll tell you what is or isn't in a block. I think that's fine.
Okay.
But
you're trusting the Electrum server, right?
But you're trusting them, and you know who they are.
So having a trusted server somewhere is a fine way for you.
The problem is things like Neutrino and unfortunately Electrum now as well. They have this bizarre trust, but you don't really know who you're trusting model. That's what scares me. Right now Electrum, and correct me if I'm wrong on this, but my understanding is the current implementation that's widely used is there's a pool of servers that people kind of join up and volunteer for. Who we don't know who they are. You as a client don't know who they are. And they're giving you this unverifiable data that you have no relationship with. That's really scary.
Well, I mean, I think that's the idea behind the whole Neutrino protocol. No?
Yeah, and I think that's really scary. But problem is your client isn't verifying it, which makes tons of incentives for people to attack this and
wait.
miners to attack.
What aren't you verifying as a client, sorry?
Well, the problem is what all you're verifying is that essentially some miners claimed a transaction was in there.
So I think part of the Neutrino proposal is that there would be a Coinbase op return commitment.
Yeah, but that's miners. That is miners committing and making a claim. That's incredibly dangerous because now you have given away this trust to a group of people who can self-select by buying a bunch of hardware. That's the sort of thing that makes 51% tax profitable.
So you have this commitment. You're saying that because that commitment was put in there by miners and you can't independently verify it, that it would be bad for the
a light client isn't independently verifying that. They don't know that commitment's correct. Thus, now you have this massive incentive for miners to use their hashing power to screw over people by putting garbage in there that isn't correct. You have to be in an ecosystem where the people you trust, you know who they are and that you're trusting them. This is why, again, services like Coinbase are a much better alternative than things like Neutrino because I know who they are, and if I don't like that particular Coinbase, I can go pick someone else. If I don't trust Coinbase, I can instead trust Blockstream. I can trust the server I have on my computer. I can trust an N of M of all three at once. That's a much better outcome than, I just go trust whoever has hashing power. I don't really know who they are. People can buy this.
Despite the rest of the network perhaps also doing that validation of that.
That's completely meaningless. You have no idea who you're connected to.
Well, I mean, it could be majority of the net. You could connect
How
to
do
a
you
lot
define
more.
majority? This completely fails in the face of Sybil attacks.
That is true. That is true. But I mean, there can be known nodes, no? Like,
But that's what I'm talking about. A
blockchain
known
of,
node is an example of like Coinbase and Blockstream.
Right.
You know,
Sure.
Neutrino is just this intermediary that doesn't work with how they're proposing to implement it.
Okay. Well, Johnny.
Well, I'd say it works, but you've dramatically worse trust properties than under conditions like Peter and I both agree, which is that as long as you understand what you're opting into, then you can do whatever you want, but you have to understand that you're making direct and known trade-offs about the characteristics of your payments and your sending in payables or whatever.
All right. So it's interesting because you guys seem to both think that light clients are pretty dangerous for the network. Is that a fair statement?
Absolutely. The light client model where you are trusting miners, which is what commitments do, is dangerous.
Okay. And would you say that most light wallets then, where you have to trust I don't know which ones trust miners per your definition, but
A lot of light wallets, what they're actually doing is they're using a trusted server.
yep.
You know, that's a good model. That's a very good model.
You like the trusted third party.
Yes. That is a better alternative than having a trusted third party who you don't know and got their way by buying a bunch of hardware.
All right. And so you are in favor of a service like Mycelium, which have their own server and it trusts itself.
Absolutely.
Okay. Versus connecting to the network as a peer. Okay. All right. Good to know. All right. What time is it? Let me just check. All right. So I have a couple more questions. All right. Thoughts on Dandelion privacy and where we're going with respect to some of these technologies to sort of help not locate you.
I'll just do like a high-level summary because I'm not deep into this. Essentially, to my understanding, the Dandelion thing is about how you're broadcasting your transactions, and that there could be malicious nodes trying to basically guess where your transactions are coming from and trying to connect your physical identity with the addresses. There have been some criminal acts lately, people getting robbed for money, for Bitcoin and so on. Nobody tells us that somebody was able to actually trace them through the transactions up to their IP, up to their home or whatever. But the Dandelion thing is trying to come up with a proposal how to solve this, how you select your anonymity set of peers and how you broadcast the transactions. But this is pretty much my insight into this thing, and I let guys explain more detail.
Yeah, and unless I'm mistaken, it involves it's Greg's scheme, right? And it involves it involves nesting the transaction as an encrypted blob, and then it's handed out.
I don't think it's encrypted. It's a coin flip every time.
And then it's passed along, and then eventually is broadcast or relayed at the last hop or
I mean
within the last
based
hop.
on a coin flip.
Based
So
on a coin flip?
It's like 10% of the time it'll broadcast after one hop.
And
yeah.
the argument is that this obfuscates centralized platforms like chain analysis or whatever from necessarily geographically assigning or noting which node is responsible for broadcasting, and if you're a node that's broadcasting, you could be the node that's crafting the transaction and sending it.
And to be clear, it's widely suspected that companies like Chain Analysis are running very large numbers of Bitcoin nodes to go and try to gather this information on what IP addresses initially broadcast what transactions.
So, I mean, do you see this as, there are obviously concerns with putting it into core because it would require a large refactor according to Suhas in his Stack Exchange answer. But is that something that would improve Bitcoin's privacy properties, and is that something that you think is a significant improvement?
Oh, certainly. It's one of the reasons why we put the delayed transaction set in, which already is in. It's just a radical improvement over that schema.
I mean, it's not perfect in the sense that, in theory, someone like Chain Analysis could run enough nodes.
Sybil.
Yeah, that it would fail. But the mathematical analysis is that Dandelion has very very strong protections against this under the assumptions where it works, which is essentially chain analysis is not running, nearly 100% of nodes. Right. So I'd say, it's an obvious improvement. I mean, like anything, there's technical challenges in actually implementing it. But I mean, if it weren't for that, I'd say, yeah, put it in tomorrow.
Yeah. An incremental improvement, I think you would say. All right, so we do have some time left. I would like to invite the audience to ask some questions at this point, unless you guys have any final things that you wanted to talk about in particular. Okay, all right, over here.
All right. So I was curious, I'm sure you guys know this better than I do, but as I understand it, I wanted to touch on the point of saying that scaling, I think it was yours, Peter, scaling fundamentally in a Mimblewimble style blockchain is the same as Bitcoin. But if I understand cut through correctly, Alice to Bob to whoever, 98% goes away. You just store the, who ends up with the money. So I'm sure it's a nuanced point that I'm not understanding. So like if there's scalability there that a lot of transactions don't need to be recorded, like how does it work out that the scalability is the same?
Unfortunately, I think a lot of people misunderstood what Mimblewimble actually does there. That type of cut through requires interactive communication to truly get rid of all the intermediary stuff. And in theory, you can actually do this on Bitcoin too. I mean, it's not unlike what Lightning does. A really simple example is, well, I owe you money, but you also owe him money, so you just give his address to me. Mimblewimble adds a lot more math to that, but unless you have that communication at the time, roughly when the transaction's made, you can't get rid of those small kernels of data.
Yeah, the coordination challenge is the problem there. And Peter is correct in that without that kind of cut-through arrangement, like the kind of second order or well-coordinated challenges, the compression you get from the Mimblewimble chain is just a constant factor, and constant factors are not particularly interesting in terms of scale.
Yeah, in other words, you have to talk to everybody that's doing the cut-through in order to make it work, and that's highly unlikely. All right, let's go over here.
Okay, hi. Thanks, guys. Very interesting. Could you speak to Lightning Network opening and closing channels? I think of it as, cash in your pocket, you go out to buy something. You're not going to take your whole bank account with you. But if you're only making one transaction, the guy at the other end wants his money, you open up channel, it closes immediately. So I'm confused as to, in just a one-time transaction with somebody, the added benefit. I get the back and forth if you're going to interact over and over. So I'm just curious. I'm having trouble visualizing the efficiency if you're only going to make one transaction with one person. Thanks.
Take that, Johnny, or Jan?
Just a simple use case scenario. I would say it's more similar to as if you have money deposited in your bank, which would be your Lightning payment hub. And if I go to Starbucks here in Vegas, they would have an open channel with some other payment hub. And basically, that's where the Lightning Network comes in play, where I'm able to use the deposited money in my channel, in my open channel with my payment hub, with my bank, and just route this through the network. So use cases like this, like you want to pay a random guy in the street, they're possible, but they're not. That's not the useful use case. It's assuming that you both have this setup where you're connected to the network.
I mean, concretely, like, I use Eclair on my Android phone, and I'll have one or two channels open on my Eclair wallet to, various nodes. Usually, when I run at home, but you can also just use the, some random node or the default node. But the important thing is I can leave that channel open for months. And I have actually left it open for months. And I'm sending money not directly to the person I'm paying, but rather through 2 or 3 hops through essentially through a mesh network. Now this isn't perfect. I mean, there's downsides to this too. You have a whole bunch of capital tied up, which is a major problem. But for certain types of patterns of use cases, this is extremely good scaling. On the other hand, if you really are only doing infrequent payments, Lightning doesn't actually scale much better than on-chain transactions. And I think that's actually a fair criticism. It just depends on how you're using it.
And that is definitely a market thing.
Yeah. Again, I'm my perspective on Lightning is mostly, yes, it has wonderful scaling benefits, but I look at it as from like a fungibility perspective, where it's useful because it gives us the opportunity to abstract away the characteristics of ongoing payments from the kind of always-on world at the base layer. So to the extent that we can get kind of good coordinated behaviors on entry and exit from Lightning, we can get wonderful fungibility characteristics of the coins that are inside Lightning. But for like single person-to-person payments, no, it doesn't give you substantially better any real characteristic benefit.
And I think it's important to remember, like, Lightning does have much better UI experience and much better privacy than on-chain Bitcoin when all the software works. You know, Lightning transactions happen essentially instantly. I mean, you just can't beat that.
All right, over here.
First of all, thank you guys for keeping my Bitcoin secure. I really do appreciate you. A lot of us, I don't understand the Lightning network, and I really want to learn why. And the last question helped me a lot. But why do we really need something beyond Bitcoin if that is the standard? And then why can't what it seems like the
Are you talking about altcoins or something?
No, only Lightning.
Okay,
No,
Lightning.
Lightning. Let's
Okay.
just stay with Lightning.
Mm-hmm.
Why is Lightning really necessary if we have Bitcoin? And like Todd was talking about, there is a purpose to have trusted networks. As hodlers, we're really banks, and maybe, to get away from trusted networks. Isn't that what we as people are all about? I just want to throw that up and ask you.
I mean, Lightning isn't a trusted network. Yeah, I mean, it's a very
Bitcoin.
it's a very fancy way of creating Bitcoin transactions ultimately. And the reality is, at a technical level, to make a lot of payments quickly and with good UI, Bitcoin kind of sucks. Having to go wait for confirmation sucks. Having very high fees when a whole bunch of congestion happens sucks. It's very secure, but it trades off a lot for that security. And when you go and build systems on top of that, you can make different trade-offs that work better for different applications.
Yeah, Lightning is not the simplest thing, but it's the way I explain it to people is it's the difference between a normal Bitcoin transaction. A normal Bitcoin transaction is like this compressed, really very, very simple kernel, whereas a Lightning transaction is the same kind of transaction, but instead of a simple kernel, it's like a blueprint for how you can communicate with other people that are using similar blueprints and make payments inside that blueprint that eventually resolve to that simple kernel over time. So it is Bitcoin. It is Bitcoin. It's just a more sophisticated version.
All right, let's go over here.
Thank you all for what you do. Can you speak to the effects of the development ecosystem with the reduction in price over the last year?
Good question. How has price affected your developing?
I'd actually say a lot of the core developers, I wouldn't say they're happy about it, but they feel like it takes pressure off them. They have like SIPA and a handful of others definitely had a ton of anxiety. There's a lot of anxiety that comes from the system ramping up faster than we think it's ready. Depending on who you ask, some people wish it was still at like $200 because the pressure or the requirements upon the system are much more lighter weight. Hell, even Satoshi said that in 5 or 6 years ago or something. So
Yeah, with the WikiLeaks and stuff.
yeah. Eyeballs are always good when it comes to like sunlight cures all ailments, but it certainly ramps up some of the pressure. But I don't. A lot of core developers seem uniquely immune to it, in the sense that they consider things that most people would not to be champagne problems, and we're diligent stewards of a system that we're in transient kind of stewards of his system, and we do our best.
Either of you want to comment on how it's affected you?
Well, to us, it just makes our life a little more hard. But I was just thinking that that's what some of the altcoins and new projects are good for, where you can actually test new technologies like confidential transactions are being tested in the Elements project and things like that. So you may want to launch an alternative project to Bitcoin just to see if the technology used in there is viable, and then probably some of these things. For example, I don't know, the Elements project has Schnorr signatures and using it. So, and if it works and they don't have any problems with that, chances are that it's going to work on Bitcoin as well one day.
All right, over here.
I don't know if we have time, but I do have like two completely separate questions. So the first one is, I just want to get your thoughts from a developer perspective on the rehypothecation talk that's been talking about recently in the media. And then the second thing is, I was wondering if you guys could speak to the importance of Taproot and Grapefruit and how it ties into Schnorr, and just because I think there was a really great article recently on Bitcoin Magazine, and I would love if you guys could expand upon that.
So let's see if I can pronounce this right. Rehypothecation.
Hypothecation.
Hooked on phonics didn't work for me. But so essentially, my understanding is that discussion was about central parties holding Bitcoin and other things on behalf of others, essentially creating money out of thin air. There's lots of fancy terms that like to go use for it, but that's ultimately what it is. And I wish I'd remember who actually said this, but a really good point made about it was, in many jurisdictions, this is a criminal practice. It's considered straight up criminal fraud. And I think in the Bitcoin world, we've discussed ways of preventing this cryptographically for literally years. The earliest mentions of Merkle sum trees are probably back in 2014, 2013, 2012 even.
Yeah, some proof of reserves, maybe even as early as 2011.
Yeah, and I mean, I personally am working on tech that could be reused for this, but maybe the best way I describe it is it's kind of sad that people aren't really like pushing this. And I think what it will take is maybe like, well, we've had the massive failures. We've had the Mt. Goxes. I mean, every time I wind up doing consulting for, companies wanting to get into Bitcoin exchanges. And every time I explain to them the risks and the auditing required, a lot of times that discussion starts off with, well, you need to be able to ensure that even just to yourself, you can audit your reserves. And I will admit that basically no one I've ever done that kind of consulting with has actually gone on to launch a real working Bitcoin exchange.
Yeah,
so it's just sad.
Yeah, you have to, as consumers, especially ones that trust entities like exchanges or OTC desks or Coinbase, whatever Coinbase is these days. It's on you to push them to move towards a standard that makes those kinds of things impossible. Ongoing proof of reserve, like I said, it's been something we've been talking about for almost eight. I mean, hell, the whole life since Hal Finney, and it's not trivial to do, but it would drastically change the extent to which these conversations really matter.
Interesting. All right, over here.
So you guys mentioned usability improvements and the future of Bitcoin. One of the things that I struggle with when I get people into Bitcoin is how to get them to take security seriously, how to manage their private keys, seed backups, all that kind of stuff. What do you guys see as technological, the future of key management, and how we can get more people, to get into Bitcoin when it's so difficult and most people use the same password on all their websites, and this is just a totally different game for them?
Yeah, good question. How do you do security, guys, for the masses?
When I introduce people, it's just a hardware wallet. Like a hardware wallet's very, very accessible to people. It's something that that you can get across that this physical thing matters, and it is your money. Don't lose it. And this piece of paper, this word of strings, that thing can emulate that thing, and if you lose that, it's equally catastrophic. If not more so. To the question of how do we help people better secure their keys, I mean, humans are notoriously poor at security and operational security in general, so I don't have an answer to that.
I mean, I've found that, what it takes to secure your key is not hard. People are, like, the vast majority of the population is more than capable of learning how to go do this. The real problem is that the vast majority of the population is too lazy to do it. And that's just a problem with security in general. Like everything about security, and this is not just Bitcoin. This is things like people's Gmail accounts getting hacked. You just need to somehow get past people's laziness, and it may be impossible. There may be no good answers.
What would you say are the requirements, just for our audience? Like you said, vast majority of people are capable of doing it. What would you say are the top 5 things you would need to do?
Two-factor authentication. Like there was a really good report recently. Wire published it, but there was I think it was a Cambridge team that did it, that said like something like 97% of like computer hacks that have occurred in the last 10 years would have been mitigated by basic two-factor authentication schemes. So two-factor authentication, get yourself a YubiKey and get comfortable with its use. Get used to really uncomfortable conversations about trusting people, because like at the end of the, like I've had tough conversations with my family about about key distribution, stuff like that. It's like you have to want to do it.
What makes it tough? What are you talking about, Johnny?
Like multi-sig is the concept of multiple people having responsibility, but no one singularly having responsibility is a bit of a jump for the average person right now. It's one of the reasons why I think two-factor authentication is not used so much, is that people they have trouble overcoming that kind of disjointed security model.
But multi-sig on bank accounts is actually pretty common.
In the sense of like marriage?
No, it's very common for bank accounts to require dual signing authority.
Yes,
I mean,
yeah.
I have long story short, is for a business reason, I have a bank account like that, and you have to do dual signing authority. It's a very common thing, and accountants are very familiar with it.
I'm not sure our audience is, but okay. Anyway, all right, let's move on, because we still want to get to more of these questions over here.
It's a mining question. Do you feel like there's a more of a march towards like consumer commodification of mining equipment? And me, like my specific example is, I have solar on my house, so there's like at any given moment, I can probably guarantee at least 100 to 200 watts I can give to mining. It's sometimes during the day I can give 3, 4, or 5 kilowatts to mining. I might have that for a half hour, and then suddenly a half hour later I only have 500 watts. But the most efficient mining equipment only comes in increments of 1,000 watts.
I have an input on this. We made these calculations even for bigger entities lately, like somebody who owns a power plant, and they would be like, okay, so we have these times where we literally have to send the power down the earth because it's not worth selling it. But it turns out that the price for the equipment that you would need to pay to absorb these spikes of power would be so high that it would be worth actually running it full time. And that's exactly your case. You have spikes of 3 kilowatts, but you don't have it like 12 hours a day. You have just like 1 hour.
Right.
In order to absorb like 3.4 kilowatts, you need like at least 2 or 3 units, which is probably, I don't know, today with these prices, something like $5,000, I don't know. And then when you look at the actual mining profit, you would be actually ruining your investment, because on the long run, the difficulty starts rising, so you're like earning less and less and less and less and less. So such an equipment would never pay off, even if you literally have like almost free energy, because you cannot run it full time. So back to the original question, I don't think the mining equipment is going to get commoditized, at least not in Bitcoin. It's actually moving towards bigger farms, and actually those farms are going to be movable in terms of searching for the cheapest place with the cheapest electricity rate.
Like an important question to ask in your case is, what's cheaper per kilowatt hour, that you can absorb, Bitcoin or lithium batteries?
Yeah.
Ground.
Over here.
What is the current state of core developers as far as like number and quality? And I say this in the context of, I'm not a developer, so do developers tend to get really involved in something and then not necessarily get bored, but want to move on to something else? So do they move on to other projects, or do they get really good at it and super competent and stay with it and just get deeper and better?
So it takes about 9 to 15, 18 months for like a really well qualified C++ engineer to contribute meaningfully to Bitcoin. So it's a pretty serious ramp up time. And we've gotten better at making it easier for people to come in, to join that ramp up, in the sense that we encourage them to do things like write tests and start to learn the componentry of the system. And it can be frustrating for new people, especially in the sense that if you want to contribute, but the context for development is often one where we don't touch things for a reason, or we are extremely conservative for a reason, and that is very different from the vast majority of projects across the entire world. In the sense that there are not that many super qualified C++ developers in the first place, it's a little bit challenging. We're obviously always looking for qualified and competent people, but it's definitely it's a tough game to get into.
I think like there's too much focus on Bitcoin Core development. You know, Bitcoin Core is like one part of the ecosystem. There's so much other interesting things. I mean, there's an entire ecosystem of Lightning stuff out there that's worth contributing to. You know, me personally, I haven't touched Bitcoin Core for a few years now. You know, and I certainly don't regret that. I think there's more interesting things I can do with my particular skill set. You know, I mean, all the more power to people like Peter Wool, who do great work, but they have a skill set that's different than mine, so they should be doing what they do, and I should be doing what I do. You know, and don't feel like Bitcoin Core contributions is the only way to do things.
I think there's also like no general developer, right? Like not everyone's the same. Everyone has different motivations and skill sets, like Peter was saying. And it's, you know, like people do things for their own reasons, and it's hard to sort of generalize in that way. So, but yeah, I mean, I think we can say that the number of developers has been increasing. I think that's a trend that's up and to the right, so that's a very good thing. Over here.
You guys briefly made a comment about quantum computing and not really thinking it's something that could happen. I was just wondering if you could expand on those thoughts about your
quantum computing.
You could always ask Vitalik about that. He was wasn't he fundraising for a quantum computer before he started Ether? That was going to.
It wasn't Google Glass or something. I can't remember. Yeah.
Well, I actually used to go work in a different line of work where, I mean, one of the things I did was design a squid controller, which is similar-ish kind of tech to what a lot of quantum computing has. So, of course, then I was at a job where you had all these physicists who knew all about quantum weirdness and quantum computing superconductors. And it was always funny asking them because their view on it was basically, yeah, quantum computing might be a thing, but chances are the way it scales is that as the number of qubits go up, the price of your computer goes up exponentially. And so far, that's looking like it's a reasonably good prediction. And if that scaling law holds true, then no one's ever going to build quantum computers that can actually go break crypto. You know, it's just not going to happen. It'll be too expensive.
Yeah, I think Lockheed spent like $300 million on a quantum computer that factored 15. So I'm not really worried about that context, really. I mean, maybe 20, 25 years from now.
I would call it an unknown. You know, right now we kind of know quantum computers could maybe in theory work, but like we just don't know that what the challenges will actually turn out to be. You know, you might as well go ask, like, will encryption get broken back in the 1850s? Who knows?
The other thing is, you know, quantum computing requires some serious engineering. A lot of the quantum states that you get are at nano degrees above absolute zero, and you have to keep it there, and you have to have all these error corrections, and there's like decay and all this stuff. The engineering reality is nowhere near where it needs to be in order to do something like 2 to the 80th operations on a quantum computer in order to break something. So
I mean, I spent like years of my life with a dewar of like liquid helium sitting by my desk. And it's just, you know, it's just mind-boggling how hard it is to make this stuff actually work. You know, I was at a position where I could literally like tap the cables going into this liquid helium dewar. And when you tap the cables, you literally physically push electrons around, which is enough to go throw the system out of coherence. Mm-hmm. It's a nightmare.
All right, over here.
I understand the advantage for better hash from a user and developer perspective, but how about from a miner's perspective? Is it a welcomed addition from centralized large pools?
Better hash.
That's been a heated topic lately. The fundamental problem that we have to think about is what is the better hash bringing as a new improvement. Obviously, we need to fix the mining protocol in the long run. The current one is not very efficient and so on. It's not secure. At the same time, when you talk to the big farms, they just say, well, if we switch this, is it going to work? What if I'm going to lose? Like, such farm is making like, I don't know, 20 grand a day or something like that. If we make one mistake, they're not going to be very happy about that. So it's sort of like we have this like legacy thing, something like the Bitcoin core developers are saying, like, we have certain things we don't like to touch. Obviously, we want to touch it, but we want to be sure it's going to be a significant improvement. The situation with BetterHash is currently being discussed. We have some objections, what we don't like about the current proposal. I can mention a few, but we want to come up with something that would really be a substantial improvement.
So I don't know, but is this like an open hash variant, like where the
No,
pool?
better hash
it's
is
a binary
replacement for Stratum.
It's a replacement for Stratum, which I didn't summarize. Sorry. It's a binary protocol, which is one improvement. It has some security features. Some messages are signed so that you can actually authenticate whatever is coming to you if it's like from the real mining server. And one central idea of the better hash is that it's separating the role of the pool and the work being fetched by the miners.
The block construction. To the
but there's a problem with it. And the problem with it is that essentially, in that case, if you leave the work selection onto the miner, what's missing in the protocol is that you actually don't check with the pool where you're submitting the work that the set of transactions that have been constructed are something that you like and that is valid. Yeah. So if there was like one thing that needs to be at least fixed, this is it. And there's like a couple more things like data efficiency and so on. So we really want to address all these specific things, and it's being discussed.
Okay, all right. So we have two more questions, and I think we're supposed to have break. So I'm gonna have to cut, and let's do last two questions over here.
Just a quick question about SegWit and after the user-activated soft fork that occurred. I thought we were going to be seeing a lot more Bech32 addressing, and what we actually ended up seeing was a lot of the kind of the addressing where they start with the 3.
Pay to script hash.
Yeah. So if the Bech32 addressing is more efficient, why was it that the adoption seemed to go that way?
Okay.
Well, I mean, I think you can ask the same question. Why hasn't SegWit been adopted by many entities? And I think the simple answer is changing things requires a lot of work, and doing work requires money. You know, it's just, I mean, I personally have a Bitcoin library, Python Bitcoin lib, that does not support Bech32, because I haven't bothered putting in, the probably 2 or 3 weeks of effort to test it and get it all working. And, it's just saving a little bit of money on fees just isn't really a big deal.
Well, I mean, the other thing is, pay to script hash is backwards compatible. Bech32 is.
Yeah. To be clear, like anything you can do with Bech32, for the most part, you can go do with P2SH. The addresses that
pay to script hash, pay to witness, pub key hash, and pay to script hash. Pay to witness,
it's just it makes it cheaper, but beyond that, I mean, kind of so what?
Over here, last question.
This may be a stupid question, but as a non-tech hodler, how at risk am I not running a node? Am I really a second-class citizen?
You should really run a node.
You're not at risk until you are, and then you're really going to feel like a second-class citizen. I mean, it's kind of not unlike saying, well, I mean, how much risk you are if you don't have some guns. 99.99% of the time, you're absolutely fine.
Well, are you doing transactions without running a full node, or are you just holding it like literally in cold storage and nobody sees it until like some future date, at which point you might run a full node to do a transaction?
Yeah, it's on a hard wallet. I mean, this is the first thing I've ever paid for. It's not
Uh-huh. So you've only spent your Bitcoin to come to this conference. All right. I think we're good. Well, thank you.
Quick follow-up on that. So what about someone that is running a node that doesn't really know what they're doing, and it's like an old node from years ago that they're not going to update, and can that be an issue?
That's better than not running a node. And you know why? Because now you have the data so that when you do update, when suddenly something does happen that this actually matters, you're all good to go.
And technically, the security model of Bitcoin benefits from someone running an older node because we have a nice distribution of node generations. So in the event that we made a mistake or messed up, you're actually helping to contribute to the
It
security
is
network.
backwards compatible. That is a nice feature. All right. Well, I want to thank the guests on the panel. Obviously Peter, Johnny, and Jan.
Thank you.
I think Tone will give you an announcement about break. Here you go.